Alright, so in this lecture we're going to focus on the concept of asynchronous to make sure we have the same understanding of this concept throughout this course. So the concept of asynchronous makes sense when we talk about the communication between two entities. And if we take a very simple example, let's say that we have Alice and Bob and they want to communicate using email. So Alice sends an email to Bob and Bob is not able to respond right away. So it waits some time, let's say a day or two, and then it responds back to Alice. Now in this time frame between the moment when Bob received the response and the moment it answered, Alice is basically free to do any kind of activity. So she doesn't wait actively for Bob to respond. So we basically say that Alice and Bob communicate asynchronously because they are not actively waiting for each other to receive the email. Now, of course, this is contrary to the synchronous communication model. And to take an example of that, let's say we got an HTTP client, which can be a browser, for example, and an HTTP server, and they want to communicate, right? So the client sends a request to the server, let's say a GET or a POST request, and the server has to respond right away. And the server responds with the data that was requested. Now, in the meantime, the client actually waits for the response to come back, right? When you're going on a website using a browser, there's a GET request which gets launched to the server where that website is hosted, and the browser waits for the response with the actual website content to get back. So in this communication model, we say that the client and the server communicate synchronously, right? Because the client waits for the server to respond, right? In order to take the next action, to do the next activity, if you want. And of course, we have asynchronous HTTP clients and things like that, but we're not going into that area for this lecture. It's very important to understand like the difference between asynchronous and synchronous communication models. Now, a very important thing that we should understand is why do we need asynchronous programming or asynchronous communication models in software engineering? Well, as you probably have guessed, those two entities that we are actually talking about are actually threads, right, in programming world, especially in Java programming world. And the main goal of asynchronous programming and asynchronous workflows actually is to make sure that our threads are free when they're not actively communicating with other threads. So we don't want our threads to wait for other threads to do their job. We want them to be able to do other things, other tasks, and when the background processing is finalized, they should be notified, right, asynchronously. This is the main goal actually of asynchronous programming. And the main advantage of this programming model is that we have better resource utilization. And specifically, we're talking about CPU utilization. Because threads, instead of waiting for other threads to do their job, to get data from a database, for example, they can basically be used to do other useful tasks, right? To get more requests, to dispatch other operations, and so on, right? Now, if we take a look on a more, let's say, real-world example where we got, let's say, a web application with one request thread and one database thread, the request thread basically takes care of accepting requests, right, from the HTTP client, and the database thread, let's say, takes care of the communication with the database. So we get a request, the request thread takes it, and then it dispatches the request to the database thread to fetch some data for that request. So let's say that the second request comes by and we have an asynchronous programming model and the web framework. So the request thread dispatches the request to the database thread to fetch data for the second request as well. Now, because we have an asynchronous framework, the database operation for request 2 can actually be executed faster than the one we got for request 1. So for that reason, the response for request 2 can be delivered faster to the request thread. And because the request thread can process tasks asynchronously, can simply dispatch the response and do any kind of processing on it to the actual client. And later on, when the database response for request 1 is finalized, it can also do that for that request as well. So this is basically a valid execution chain for an asynchronous web framework, which basically takes requests and dispatches them to a database thread. Now, just for the sake of exemplification, if we have, let's say, a synchronous web framework, this order cannot be possible, right? The only possible chain of operations here would be something like that, where we got the first request, it gets dispatched to the database thread, and the request thread waits for that response to come back and to deliver that response to the user, and then the next request comes by, it gets processed, and so on, right? So the request thread cannot accept more requests even if it doesn't have the data for the request that it already accepted, right? Because the synchronous web framework model does not accept this. So this is how asynchronous workflows actually work in real life.